All right, so for today, we're going to work on multiplying polynomials. Tomorrow, when I come back to school, we'll go over the homework from I think it was pages 409 and 417, if I'm not mistaken. But, whatever they were, we'll go over those 2 pages. But for today, I want to focus on multiplying polynomials. The main difference here is that you got to be really careful about what you do with the exponents. When you add and subtract polynomials, the exponents don't change, just the coefficients. So I'm just going to make a little note. You all added and subtracted polynomials. So I'm going to put adding and subtracting polynomials. Exponents don't change. I will tell you, when you multiply polynomials, the exponents will change. Always when my students get confused, I'm write that in a little better. My students always get confused on that part. On this, they don't change. On multiplying, they do change. Okay? All right, but to multiply polynomials, normally we just use some form of distribution. Now, you all have just learned about just regular distribution, where you distribute a number times something on the inside of parentheses. But you can distribute terms as well. When I say terms, I mean those terms or algebraic expressions that can contain variables, guys. And you can distribute more than one term. You haven't learned that either. It may be called, instead of distribution, it may be called double distribution or triple distribution. So that'll be something new that you'll see today. Also, you'll see FOIL method, first, outer, inner, last, FOIL. You'll see that today as a way of using of multiplying polynomials instead of using double distribution. But let's go ahead and get into it. So it says distribution is one of the methods that allows us to multiply polynomials. When multiplying polynomial expressions, simplify the terms with like bases by multiplying the coefficients and adding the exponents. So when I tell you the exponents are going to change today, they're going to change because when you multiply them, you're going to add your exponents, okay? All right, so what we'll do is just go basically, like on this example, it's just strictly using the distributive property. But the only thing you're going to have to remember now is what I highlighted, that you need to add your exponents. All right, so let's take a look at it. So if I distribute here, it's going to be 3x times 2x squared. Well, I got to add my exponents, and that's an understood 1. Okay, so I know that 3 times 2 is 6. And then keep your x. You only want 1. When you're multiplying polynomials with the same base, you can write 1 base. And I don't want both of those x's. Just write 1 x. And I want you to add the exponents. 2 plus 1 is 3. So basically, I end up with 6x to the third power when I multiply there. When I multiply here, let me do this in purple. It's 3x times negative 5x. Or both of these have understood 1s. And I will tell you, when I'm doing these, and then especially they get lengthy, I prefer to just go over and do the side work first like this. Because it's very easy to chunk it and keep up with it. So I end up with negative 15x to the second power. Because 1 plus 1 is 2. And then, of course, lastly, I have 3x times 3, which is really easy. And that's what you're used to. You just end up with 9x. All right, so my answer here is just all of this. 6x to the third power minus 15x to the second power plus 9x. You're done. Okay. That's the distributive property. That's multiplying polynomials. But the main thing is, again, just remember to add the exponents. All right, it says we can use distribution to multiply two polynomials by using distribution twice. I call this double distribution, because you're distributing two times. All right, so what you're going to do, and I'm going to show you all kind of methods for these. You just pick the one you like. So they kind of have broken it up. I copied these notes from somewhere, and I really don't want this part down here, because I would rather just show you what you're going to have in the beginning and then show you how to do it, okay? So I'm going to ignore that. All right, so to use double distribution, you see that in this parentheses, you have two terms. In this parentheses, you have two terms. So what you'll do is you want to take one of those parentheses and break the terms up, so that one term multiplies one whole set. So you have to, in one parentheses, you have to break up the terms in parentheses. In the other parentheses, you need to keep those two terms together. So I'm going to choose to keep these two terms together. Excuse me. So I keep them together. Not going to break them up. For this parentheses that I didn't highlight, I'm going to break the terms up. That's going to allow me to distribute not once, but twice, okay? So when I break the terms up, I have two terms in here. I have the term x, or 1x, and the term positive 2. Those are my two terms. So what I'm going to do is take the term x and multiply it by the parentheses I chose to keep whole, which is x minus 3. Then I'm going to take the other term, which is a positive 2, and multiply it by the parentheses, or the two terms I chose to keep whole, which is, again, x minus 3. So basically, it's the first term times that whole set I chose to keep together. And then it's the second term, positive 2, times that whole set I chose to keep together. Okay? So you just use distribution. It's called double distribution. You've seen this before. Actually, we did this in 7th grade too. So I'm going to multiply there, and I'm going to multiply here. But I have two sets of parentheses now, so I'm going to use the distributive property twice. So here I'm going to do x times x. Both of these are imaginary ones. That gives me x squared. And then I'm going to do x times negative 3. That's negative 3x. So I have that taken care of. So that becomes x to the second power minus 3x. And then if I go with what's in green, it's positive 2 times x, which is 2x. And then 2 times negative 3, which is negative 6. So I end up with a positive 2x and a negative 6 when I distribute. Now the thing here is you have some like terms. When you combine like terms, guys, that's adding or subtracting. So these two are like terms. So let me go back up here. When you add or subtract, your exponents do not change. So I'm not going to change those exponents there. I'm just going to change the coefficients. I'm going to bring down x squared. I'm going to put these two together. Negative 3x plus 2x is negative 1x. And then I'm going to bring down my negative 6. Okay, so the answer to this problem equals this. All right, I'm going to go through this. I kind of went ahead of myself. It says, after we distribute, we must always simplify our expression. And this is the expression that we simplified. By combining like terms. And you just have to remember, when you combine like terms, you're adding or subtracting. Do not change the exponents when you combine like terms. Please don't. Okay? You are adding or subtracting polynomials when you combine like terms. There's no exponent change, guys. So whenever you do this part, never, ever, ever change the exponents. Only change the exponents when you're using distribution, okay? All right, it says distribution is the most effective way to multiply larger exponents. I'm going to cross out all of this and show you how to break this up, okay? So one of these, this has 2 terms. And this one has 3 terms. I am definitely going to keep the larger one whole. I don't want to break it up. Now you can. I'm going to keep that one whole. It doesn't matter which one you break up and which one you keep whole. So I'm going to keep this one, definitely. This is the one I'm going to break up. I'm going to break up the smaller one. So I'm going to break it up into x times what I'm keeping whole and positive 2 times what I'm keeping whole. So we're going to end up with x, not that. We're going to end up with x times x squared plus 3x plus 5. And then I'm going to take the 2, the plus 2, and multiply by what I'm keeping whole, which is x squared plus 3x plus 5. Okay? All right, so then I just start using the distributive property. I have to distribute twice. So we're going to distribute x times all of those, that trinomial, and distribute 2 in the same trinomial, guys. So I'm going to do my side work here, SW for side work. So I'm going to take x and multiply by x squared. Put your imaginary 1. So that's x to the 3rd power. Then x times positive 3x. Put your imaginary 1. So that's 3x to the 2nd power. And then x times 5, which is pretty easy. That's what you're used to. That's 5x. So this becomes x to the 3rd power plus 3x squared plus 5x, guys. So now I just have to distribute where I have the purple. So that's going to be 2 times x squared, which is 2x squared. I don't have to worry about multiplying exponents on this one because the 2 doesn't have an exponent, so I just use regular distribution. 2 times 3x is positive 6x, and 2 times 5 is positive 10. And then I just work on combining like terms. Well, x cubed isn't like anything, so I'm just going to keep it. But I do have some like terms. Positive 3x squared is like positive 2x squared. My exponents won't change when I combine like terms or simplify, because this is the part where I need to simplify, which means you're just combining like terms, guys. So 3x squared plus 2x squared is 5x squared. And then I have other like terms. Let's see. Positive 5x is like positive 6x. That's going to give me positive 11x. Remember, whenever you are simplifying, do not change the exponents. And the other thing that's left out is a plus 10, so bring it down. So this answer simply equals that. Well, that problem equals that. X cubed plus 5x squared plus 11x plus 10. And that's all you do. That's double distribution. All right, so I want you to pause the video and try 1 through 4. And then we'll do 5 and 6 together, okay? Pause the video and try 1 through 4. Okay, it says multiply the following polynomials using distribution. This is basic distribution. 3 times x is 3x. And 3 times 2 is 6. That's a monomial times a binomial, guys. All right, this is a monomial times a 1, 2, 3 times a trinomial. Okay, so number 2 is a monomial times a trinomial. Let's see what we get. And I'm going to do side work for number 2, because I prefer to chunk mine. Makes it easy to see when I'm adding these exponents. X squared y, that's an imaginary 1, times the first term in the trinomial here, which is x squared y. Put your imaginary 1. So we take the two x's. That's going to end up being x to the 4th power. You can only combine the exponents, add the exponents of like bases. So it's got to be the same base, x and x. This is not like finding a degree. Some of you may refer back to trying to find a degree where you add the exponents like 2 plus 1 and 2 plus 1, and you get x to the 6th power. Don't do that. You're not finding a degree. You're only matching those. So you put 1x, and add the exponents for those x's. 2 plus 2 is 4. And then you're going to put your y next to it because they match together. And 1 plus 1 for the y's is 2. So x squared y times x squared y equals x to the 4th y squared. Now you need to multiply x squared y times 4y squared. Well, that's an understood coefficient of 1. So 1 times 4 is 4. 4. Now, I don't care if you write the x or the y first. I tend to write mine in alphabetical order. So x doesn't have another match on this side over here. So just keep that x squared. And I have a y here, and I have a y over here. So add those exponents. 1 plus 2 is 3. So when I multiply x squared y times 4y squared, I get positive 4x squared y to the 3rd power. And now it's just x squared y times negative 1. Basically, it's 1 times negative 1. So then with negative 1, x squared y. These don't have any matches, so bring them back down. Now I'll look for like terms to combine here, but there are no like terms to combine, so that's the answer. Rule number 3, I'm going to use double distribution. So if I use double distribution, I tend to take the first one and break it up, especially if it's a small one. So I'm going to break this one up and keep this one whole. So I'll end up with x, I end up with x times x minus 3. And then positive 2 times x minus 3. So if I work on the first part, what I have to distribute, let me highlight this, just color coding, and do my side work over here. X times x. Put your imaginary ones. So write 1x and x times x. Add the two ones, I get x squared. Then I have x times negative 3. So I end up with negative 3x. And then this doesn't have an exponent, a variable out here, so I just do regular distribution. 2 times x is 2x. And 2 times negative 3 is negative 6. And then I have some like terms. Negative 3x is like positive 2x. So that's the part where I'm going to simplify. When you simplify, do not change the exponents. So I'm going to bring down x squared. Negative 3x plus 2x is negative 1x. And put minus 6. And that's the answer here. Now I'm going to have to erase this to do number 4, guys, okay? So make sure you get it copied. You can pause the video if you need to and copy. All right, let me erase it. All right, so to complete number 4, I am going to break this one up into 3x and positive 4. And I'm going to keep this one the same, guys. Keep this to the parentheses the same. I'm going to keep it together. So it's going to be 3x times x squared plus 5. And then plus 4 times x squared plus 5. I'm going to distribute and do my side work. 3x times x squared. Put your 1. That's going to give you 3. And then add your 1 and your 2. 3x to the third power. Then you have 3x times 5, which is 15x. The 4 doesn't have a variable, so I just use regular distribution. 4 times x squared is 4x squared. And 4 times 5 is 20. And there are absolutely no like terms. So you're done with that one, okay? All right, 5 I want to do with you. I am definitely going to break up the binomial. The smaller one, 4x squared, and then a positive 5x. And I'm going to keep this large one here, which is your trinomial. So I'm going to take 4x squared, and multiply times. And I'm going to put an imaginary 1. Negative 1x squared, y, plus 2x cubed, minus 2. Then I'm going to take positive 5y, and multiply times the same polynomial or trinomial. Make sure you're taking notes. Then I'm going to do my side work here. 4x squared times your first term, which is negative 1x x squared y. That gives me negative 4x to the 4th y. Add the exponents for the x's. Then we're going to take 4x squared and multiply it by 2x to the 3rd power. 4 times 2 is 8. Write 1x and add your exponents. 2 plus 3 is 5. So that's going to give me positive 8x to the 5th power. Then you have 4x squared times negative 2, which is negative 8x to the 2nd power. And then you have another set. So let's get busy with the other set. Here you have 5y times negative 1x squared y. Put your imaginary 1 on that y. 5 times negative 1 is negative 5. Keep your x squared. There's nothing else to put it with. Write your y. But both of those are understood ones. 1 plus 1 is 2. So you put negative 5x squared y squared there. Here you're going to have negative 5y, positive 5y times 2x to the 3rd power. Well, you only have the coefficients you can multiply. And write your x to the 3rd power and your y here, because there's nothing to put x or y with. You don't have another x or another y, so just mash them together. So that's going to end up being positive 10x to the 3rd power y. And again, I tend to write mine in alphabetical order, so you could put y 10 y to the y x to the 3rd power, but I like to write mine in alphabetical order. And 5y times negative 2 is just negative 10y. And at this point, I start looking for some like terms, but I don't think I see any at all. I don't. So that's your answer. That's all you do. Okay, I'm going to go back up and do this one. All right, so this one it's going to be kind of long, guys. It's x plus 2 to the 3rd power. So basically, it's x plus 2 times x plus 2 times x plus 2. And let me show you what you're going to do if you get something like that. If you get something like this, you're going to distribute these back to and ignore that first one. So if I just pretend like I have x plus 2 times x plus 2, and I'm going to do side work. I'll do it right here. Again, I'm just working on this part in green. So I'm going to take the x plus 2, this first one, and break it up. And I'm going to keep this one the same. So it's going to be x times x plus 2 plus 2 times x plus 2. X times x gives me x to the 2nd power. And then x times 2 is just 2x. Here 2 times x is just 2x. And here 2 times 2 is positive 4. At this point, I'm going to simplify. When you simplify, don't change the exponents. So you're going to end up with x squared plus 4x plus 4. So this part in green over here changes to x squared plus 4x plus 4, guys. And this part in black simply comes down Now this looks something like that, or like this up here. More so like this. So you just use double distribution again, okay? All right, so now let's just work on that. Now for this part, now since I have the stuff in green down up here, what I'm going to do now is I'm going to keep this one whole and break this up into x and plus 2. And I'm going to erase some of this stuff so I have some more room to work. There we go. All right, so now I'm going to have x times the trinomial x squared plus 4x plus 4. And then plus 2 times the trinomial x squared plus 4x plus 4. So I'm going to multiply here. Get my side work. X times x squared. Put my imaginary 1. Gives me x cubed. X to the third power. Then we have x times 4x. Which is 4x squared. Because you're going to add the 2 ones. 1 plus 1 is 2. And then x times 4 is just 4x. Here I'm just going to use regular distribution. 2 doesn't have a variable. 2 times x squared is 2x squared. 2 times 4x is 8x. And 2 times 4 is 8. Then I'm going to simplify. Remember, when you simplify, you're not changing the exponents. 4x squared is like 2x squared. And positive 4x is like positive 8x. So I'm going to combine like terms. So it's going to give me x cubed. And 4x squared plus 2x squared is 6x squared. And then 4x plus 8x is 12x. And then put plus 8. Again, when you simplify, make sure you're just combining like terms and you're not changing the exponents. Only change the exponents when you multiply or use the distributive property, okay? I don't really think I'm going to do 4 today. Well, it's only 3 problems. Let's just go ahead and get it out of the way. 4 is another way of multiplying 2 binomials besides using double distribution. Okay, so this is just, let me erase that. That's not what I wanted to put. Another way to multiply, if this thing is so slow, 2 binomials. And when I say 2 binomials, I mean like x plus 2 times x minus 6, okay? That's a binomial with 2 terms times another binomial with 2 terms, okay? Consisting of 2 terms. Now, I taught you all to use double distribution. Where you break one binomial up or break one term up or parentheses and keep the other parentheses the same. So I taught that method, but 4 is another way of multiplying 2 binomials. I will say this, 4 will not work on something like this. Because this is a binomial and this is a trinomial, guys. FOIL will only work on two binomials, which is why I always really just teach